able to have additional packages installed, and it's easier for us to work around with it. You can, of course, just have these copied from my end over to your end. I can just paste these in a Google Drive or something, and you can just paste them across into your library directory site packages as well. Another way to do it, again, just so we are aware of it, is once you go to pip.org, and if you search for ice cream particularly, and you go for ice cream, I believe there's a way to download the files. Yeah, there we go. Once you go to pip.org and you go to any particular, let's say, package, you have the ability to download the packages directly, the source distribution of it. Once you download it, it should be a zip file that you can extract. So I'm just gonna try it out here. Yeah, it should just be a zipped file that you can open up and extract. And this is basically gonna have this exact directory, ice cream hyphen 2.1.3. And I believe you should be able to extract this directory and paste it within this lib site packages directory within your environment. And it should work fine, if I'm not wrong. Let me just make sure it has the same content, just in case. So you have built-ins, coloring, ice cream.py, version, init, and pycache. Pycache is not required, init and version. This should be fine. Yeah, guess this one directory within it, ice cream, can be extracted as well and placed here inside packages. So once you go to all these directories in the zip file, you'll find a directory just called ice cream. You can extract it to the site packages directory, and I believe it should work fine. You don't need this distribution info compulsorily. I believe it should work fine, just in case, in the worst case scenario. But yeah, by lunch break, I'll provide all the list of packages. Also, we would not require all of these packages for today. For today, particularly, you can use a print if you'd like. Um, that should be fairly good enough instead of IC. I just do this only for our initial debugging purposes to make it easy. That's the only purpose. Right. So yeah, I will be sharing the list of packages I had for sure. All right. So you can raise a ticket on that. Thank you. So I guess we can move ahead. Is there any other query that you would like anyone would like me to answer? Right. I think we might be good with this. All right. So let's move ahead. So I'm just going to create a new file here. Let's call it as 02 strings.py. And let's begin with this. Now, strings has a lot of functionality within it. There are a huge amount of inbuilt functionalities when we talk about strings. And that's exactly what we're going to take a look at right now. Let's start with the first functionality. As we know, we can use a string with a single quotation, with single characters, or double quotations with single character or double characters or multiple characters. Now, since we know that string is a class, again, I'm not going to go into the concept of object-oriented programming right away, but for every class, we have objects that we can create, and we're going to use that exact concept to create some objects for some particular classes. Let's go ahead and do that. Let's go ahead and try that out. Now, first thing, let's take a simple string called hello to begin with. Now, before we start working on strings and understanding these in detail, there are a few other things in Python, a few other constructs in Python that we need to learn simultaneously as well. This is where I just want to point it out in prior that um, we will not be able to purely stick to strings to learn strings alone. There will be other constructs that we'll need to include in between, constructs such as if condition, for loop, while loop, and so on. And whenever we do that, we will incorporate those logic along and try to learn it simultaneously. As again, since this is day one of the basics of sessions, and some of us are new to Python and new to these programming languages, I will be going through these in a little bit little more advanced concepts. Things are gonna pick up to a point where hopefully most of us should be at the same level, and we can learn the next part of things or next kind of concepts ahead in an easier way. Anyway, moving ahead from this, let's take a simple string like this. Let's call this as str. Before I continue ahead, one important point. Please do not name any variable with a class that exists internally within Python. I'll just print string and I'm just going to run this. You can see it will print hello. However, you're going to run into some problems over time. If you want to convert string to a string, it'll understand that this is a variable and this should be a function. That's the idea. But if you take a look at this, it says string object is not callable. What this essentially means is, since you have a local variable called string, you will not be able to access the class called string ahead in time, because everywhere the local variable or the variable that you have within your current program always takes priority over the classes that exist within Python. You will always have your local values take priority, which is why we never try to name any variable with the same name of some inbuilt data type or inbuilt class which exists and you might want to use it ahead in your code. Just something we need to know. Similarly, the same thing goes for your file name as well. Never try to name the file name as a package that you might use, because that also creates some codependencies which will become a loop that we'll see ahead in time though. So let's just replace this name as string, because string is something we don't have any default class name as. Or you can just call it a string1 or s1 or anything like that to name it easier. Right, naming conventions aside, let's go into this. Now, there's another way to write string as well. You can write s1 is hello. You can write s1 as hello with double quotes, or you can also write with triple quotes. Now we remember that we have used triple quotes particularly for the purpose of comments, but you can also use triple quotes for strings, especially when you want to write multi-line strings. Like let's say, for example, I have, hi, this is the second line, and this is the third line, for instance. I will not be able to do that with strings as it is when I use either a single or double quotation. We can do that with triple quotes. So if you end up printing S1, it'll take the latest value, which is, of course, will take only the latest value for our reference, which is going to be hi, this is the second line and this is the third line, and they will print in their appropriate lines as expected. Now, moving ahead from here over to the next part of it. Now that we know this basic idea of multi-line strings, let's move on to the next case. Strings are essentially arrays in Python, which means we can index them. In other words, if you have a string, something like this, Let's just take something like this. Each character of the string is going to be identified with its own index. We have index 0, 1, 2, 3, 4, 5, and 6, something like this. And indices always begin with 0. Before we go ahead, since we have a few programmers in this session, just as a query, um, do you guys know, or do you know why indices always begin with 0 particularly? Right. All right. So I'll just walk through that if it's all right. So here's the whole idea. This string has multiple characters, and each character has its own address. Each character will be stored in its own unique address in the memory, and all of these characters will be stored according to the idea that they will be stored one next to another. Each of these characters will be stored one next to each other within RAM or within memory. If this is stored in address 100, this will be stored in the next address, which is 101. This will be stored in the next address 102, and so on. And I'm writing 100, 101, 102 because each character takes only one byte of information, which is not as important as we need it to be, but it'll become important when you want to create some very memory efficient programs ahead in time. That's one thing we might take a look at. But yeah, moving back to this current logic. Once we realize this, once we see and observe this, if you want to access first character, the first character is accessed with the starting address. So the basic idea of a string is that internally within Python and all other programming languages, and what I'm about to say is going to be highly important when we start to do large scale data analytics, and many of you might already know that when we work around NumPy. But just to give a brief about it, this string S1 is going to store the address of the first character. Address of the first character, let's say, is 100. So let's consider this as 100, 101, 102, and so on. Internally, what Python does is, given it's storing 100, if you want to access the first character, you need to add 0 to that address because that's the starting address. That's where you get the first character. If you want to access the second character, you're going to take 100. And since it's the second character, add 1 to it. You're basically going to get the second address. That's why the index 1. So whenever you use an index within an array or within a string, you're basically telling your programming language how many addresses to move forward and access the element. It's not just index, it's specifically about address. But for our easier understanding as programmers, we generally assume that it's an index, which is going to be able to help you access the element within that index. And we're going to understand it in that way and work around it for now. So let's start with this. In our case, if I print S1 of 0, okay, I have to import my screen. Once we run this, you get to see S1 of 0 is going to print the value h. So S1 of 0 is going to print the value h. That is the index 0 of it. That's how we get to access the value. Similar to 0, you can access any other value. Let's say you can access S1 of 1, which is going to give you the second index, and so on and so on and so on. I haven't saved this file, so let's save it and try it again. S1 of 1 is going to give you I, and so on. So this is basically how we get to access these and how we get to work around these to begin with. Now, with this idea understood and with this logic known, let's go on to the next case very quickly. The next case here is to begin with. Instead of a large string, let me just take a smaller string to begin with, so that we can play around and work around this in a much easier way. Right. So to start with this, let me take S1 as, let's say today is Monday. Let's just take Monday, for instance. It becomes easier for us to just resolve it. Let's take, and I'll add an exclamation just to add it along. There we go. Now, moving along with this, I'm just going to print S1 of 0, as we already know what's going to happen. S1 of 0 is going to print character at index 0, which is M. Similarly, you can print S1 of 1, 2, 3, 4, 5, and so on. Now, the unique thing about Python here is it's not just about printing indices in one direction. You can access indices in the reverse direction as well. What I'm trying to point out, or what I'm trying to say here is, you can access indices in the other way around from right to left. To do that, to access the last index, you can use index minus one. Minus one generally in our logic indicates minus one, which doesn't exist and it should give an error. This is the scenario when we look at other programming languages like C, C++, and Java. However, in Python, minus one indicates the last element. Then you have minus 2, minus 3, minus 4, minus 5, minus 6, and minus 7. So you can access any index in the reverse order or in the forward order as well. And that's exactly what we're going to do here. The moment I perform S1, or the moment I try to print S1 of minus 1, the idea here is that we're going to try to access the last index, which is going to be negative 1. And it should print exclamation to us. So let's see how that works out. So when you run this, okay, let's see where okay, I have not saved this file again, just one minor mistake. And you can see exclamation is printed over here. And that's basically how you can access any index. And that's basically the whole idea of it. This is about the basic idea of indexing or indices. If this idea is clear, we're going to go one step ahead within this and try to work around this um, in a slightly more complicated way so we can perform more operations on this. So again, if there are any queries still here, feel free to let me know. I'll just give you a few seconds and we'll move ahead to the next part. All right, moving ahead. Let's go on in that case. Right, now that we know about accessing indices in this way, there's another way we can walk through the entire series of these elements and access these indices as. That is through slicing. This is quite an important part of accessing any array or any element that has a list or a series or a multiple set of elements within it. And it's something that we will see over time. It's something that most of you who work as data scientists or data analysts already are well aware about. And that's exactly what we're going to look towards working on. Instead of accessing just one index, like either 0 or 1 or 3 or minus 3 or so on, you can access two indices, or you can access a series of indices by providing a start index and an end index. Let's say if the start index is 0, make sure the start index is 0. Let's say if the end index is 4, make sure the end index is 4. In this case, it's going to start from 0. It's going to print the value within index 0. Then it's going to increase it to it by 1. print it, then it's going to increase it by 1 again, sorry, to 2 and print it, then it's going to increase it by 1 again to 3 and print it. And when it increases by 1 again to 4, it's not going to print it because that's the end index. The logic is that end index should never be printed. You should reach till the end index. The moment you reach end index, you're supposed to stop this looping of this slice. And that's how it works, only to print from 0 to index 3. We can perform a lot of different combinations within these, which we're just going to take a look at. I'm just going to write here print of S1 of, or instead of print, I'll just use ice cream for this. I'm just going to write here with some comments because there are a lot of rules that we will look at within this. We have a huge amount of rules that we observe here. So I'm going to specify each one in detail so we don't forget them basically. Let's take a look at that. You have in indices start to stop. So the idea is that print from start index, sorry, uh, until you reach stop index, increasing the index by 1. This is the default logic. There are some modifications of it which we'll see ahead. I'm just going to use IC of, let's say, S1 of 0:4. Same thing as we tried before. You can see S1 of 0:4 is going to print exactly MOND because it's only going to print from 0 to 3. You can make a lot of combinations within this, something like, let's say, 2:6, and run this. It's going to print from index 2 until index 5. It's supposed to be NDAY. There we go. So a lot of combinations like this can be performed. A lot of operations like this can be performed. You can also do this in the reverse order. Like, let's say, -2 to -4. That means it should go from -2 to -4, which means it's going to print in the reverse order. It should print YAD. Let's see if it works as expected. If you print this, you'll get nothing. So it's supposed to go from -2 to -4, right? But it doesn't print anything. That's because you see the default idea is it increases the index by 1. That's the default idea of this. It's always going to increase the index by 1 by default. It's not going to decrease it. So that's the first thing you need to know. So if you try IC of S1 of -2 to -4, this is going to give empty output because default step or increase is 1 at a time in increasing order. And here's the problem. When you write -2 to -4, the condition is -2 lesser than -4? Only then print it and increase. In this case, is 0 lesser than 4? Yes. So print the value with an index 0 and increase the index from 0 to 1 and check if 1 is less than 4. Here in our current case, when we compare -2 and -4, -2 is less than -4. This is false. It's greater than -4. Hence, it says everything in this that's supposed to be printed is already printed. The start value is greater than the stop value. So there's nothing to print here. And I'm just going to stop printing it. So that's one thing that we need to know. To avoid this issue, to avoid this particular problem, you can use 2 colons and separate 3 values. The first will be the start index. The second will be the stop index. The third will be called something called the step index. The default value of step index is always 1, indicating that you move 1 character ahead at a time or 1 element ahead at a time in this series of elements. These are characters, these are series of characters. In this case, let's start with the same. I'm going to start with index 0. I'm going to stop at index 7. We know 7 does not exist. It doesn't make a difference to us because we stop at 7, which means 7 is not printed. So it doesn't matter to us whether 7 exists or not. As long as 6 exists, that is fine. And what I'll do here is, by default, when you write 0:7, it will increase by 1 at a time and it'll print each value. Instead of printing one at a time, I'm going to increase by two at a time, which means your initial value is zero. Is zero less than stop? Yes. So print it, which makes m printed. After that, since step is two, again, the default value is one. Default is one, but we are specifying two. Since it's two, it's going to increase by two. It's going to go to n. It's going to print n, and then it's going to increase by 2. 4 again is less than 7, so it's going to print mna, and then again increase by 2. 6. 6 is less than, again, the stop value, so it's going to print the exclamation. Then it's going to increase by 2 again to 8, and 8 is greater than or equal to stop, so that's when it's going to stop and not going to print anything further. Your output is going to be mna exclamation, for example. Let's just see if that works as expected. So the next thing we need to know here is start, stop, and step. So the idea here is that default step is 1. It can be changed however you want. In this case, when you print IC S1 of, let's say start at 0, then 7, then 2, you will get the same output as we expected, which is MNA exclamation. Before this, there are a couple of other things that I have not pointed out that I haven't specified properly. Let's go ahead and do those as well, because I've specified the default value of step, but I have not specified the default value of start or stop. Let's do that. Now, here, I have not specified any value for start. Default value for start is 0. If you skip it, it's going to have a 0 value as default. In other words, if I just write, let's say, stop as 3, let's ignore step for now. At this time, if I ignore start as well, by default, it's going to be 0 whether you write it or not. If you write something, it's going to overwrite the 0 as the default value. In this case, it's going to go from 0 to 2 because default start is 0 whether you enter it or not. So if I write 0 to 3, let's say for instance, and if I run this, you get to see S1 of empty start to stop is exactly MON. Similarly, you have a default stop value as well. Default value for stop is length of the series. Whatever is the length of the series, that is the default value. If I write IC of S1 of 3 colon nothing. So stop value is empty. Since stop value is empty, by default, stop value will be the length of your entire series. The length of your entire series is not the last index. It's the number of characters. That is 1, 2, 3, 4, 5, 6, and 7, which means it's going to be 7. So it's going to print from 3 to 6 because 6 is still less than 7. So it's going to be printing DAY exclamation. That's because the default stop value will always be the length of the series of elements that you have. Hence, you get DAY exclamation here. These are just a few things that we need to know because we're going to use these constantly a lot. Those who are already familiar with Python and are already working on Python with their own, let's say, projects and data analytics particularly might be very well versed with this. But it's just something that we need to know just for our reference. Before we go ahead, again, as usual, if there are any queries that you might have till here, please feel free to let me know. If there are no queries, we can move ahead to the next part. Right. I understand that this might be a lot of information for some, or it might just be a simple refresher for others. So, regardless if there are any queries, please feel free to let me know. If there are no queries, we can move ahead. All right, perfect. So no queries ahead. In that case, let's move ahead to the next case, next part. Right. Now, I have a simple question to everyone, a very simple question. I just need you to figure out what would be this series of start, stop, and step. If I want to print this string in reverse, if I want to print this entire string in its reverse format or in its reverse logic, what would be the start, stop, and step? That's pretty much it. You can think of it and try it out, and then you can let me know in the chat window here. I just need you to print the entire string in reverse. What would your start, stop, and step be? You can take a couple of minutes of time. Also, if you have any queries in between, you can ask them as well. But I want you to try this out for a couple of minutes. Let's see if you're able to work around it. All right. Um, so yeah, if there are any queries though, feel free to let me know. Meanwhile, if you would like anything to be clarified or if you want to walk through anything further in detail, or if you feel like I'm giving a lot of examples of these without going in depth about them, if you want to walk through them again, that's absolutely fine. All right, so let's take a look at how to do this. If you haven't been able to figure it out, that's all right. Or if you already know this, that's pretty fantastic. Anyway, let's try this out. Now, for me to go in reverse, I need to start from the last character, end at the first character. There are multiple ways to do this. I'm just going to point out this is one thing that we're constantly going to see in Python is that the way I approach the problem to solve versus the way you might approach to solve the problem might be completely different. So I'm going to show you a couple of ways to do this. I have to start from 6. So I'm going to start from 6. I have to stop after printing 0, which means my stop should be -1. I'm going to stop at -1. And since step is default 1, it thinks start is greater than stop and it's going to stop right there. We shouldn't have that. We need step to be negative. What this means is we're going to start at 6. Since step is negative, the default idea of Python is to see if start is greater than step, then print. So there's one small difference that we need to know here. Step can be positive or negative. If step is positive, the idea is that as long as start is lesser than stop, it'll print. If step is negative, the idea is that as long as start is greater than stop, it's going to print. So that's the difference in itself where we work around it. So let's take a look at how that works. In our case, step is going to be negative, which means as long as start is greater than stop, 6 is greater than -1, which means you can print reduce start by 1 because step is -1. So reduce start by 1 to 5. Again, see the same thing. Is start greater than stop? Yes. So print it and so on and so on. This is how you can print the entire string in reverse in one way. So let's print the string in reverse. So I'm just going to use SIC of S1 of 6 colon -1 colon -1. And if you run this, okay, let's see where we went wrong. It's giving us an empty string. Let's see where. Oh, I am so sorry. One minor mistake. Yeah, a -1 means something else, right? -1 indicates the same thing. Yeah, one minor mistake here. Stop cannot be -1 because -1 means the same thing. -1 means the same value as here. So you're specifically saying start and stop are the same thing. So please ignore this minor error that I've made. This happens when I'm constantly switching between Python and Java as two programming languages. So please bear with that. So 6 and -1 are basically the same. Since they're the same, it's not going to print anything. For us to print something, we need to skip these. And there's one thing that you need to know here. If step is negative, what are the default values of start and stop? Similarly, if step is positive, what are the default values of start and stop? So if step is positive, we know that start or default start value is 0 and default end value is length of string. If step is negative, default start value is last index and default end value is the first character. So the basic idea here is that one thing that we should always know and remember, if step is positive, it goes from left to right of the entire string. If step is negative, it's going to go from right to left of the entire string. And since we have step as negative, it's going to go by default from right to left of the entire string. And we don't have to provide any start value. We don't have to provide any stop value. We can skip this entirely so that it goes from right end to left end completely. And that's all we're going to do. If we're going to run this, you get to see, okay, I haven't saved this. Yeah, if we're going to run this, you get to see it's going to print the entire string in reverse, which is because we have a negative step. Negative step means it's going to go right to left through all characters. If it's a positive step, it's going to go left to right through all characters. And in that case, you don't even have to specify any number. You can just use two colons. Default start is 0, default end is length of the string, default step is 1. It's going to print the entire string itself. So these are some small ways that you can play around with the indices of the string when it comes down to slicing. Just some basic things that we need to know because it's going to be something that we use constantly ahead in time. So it's something that we need to know. So yeah, that's just a basic thing that we needed to know and understand. So with this, I hope it makes sense. If you're new to this by any chance, you might need to look at all these rules because I know they're complicated the first time we look at them. That's completely understandable. But if you already know and it's a kind of like a refresher, that's pretty awesome as well. So yeah, with indexing done or with slicing particularly done, if there are any queries in slicing so far, please let me know. If there are no queries, we can move ahead to performing other operations on top of strings. So any queries that you might have, feel free to let me know if you want me to go through any part of this again or any such thing. All right. Right. So I presume that it's quite easy to work around, and so far it's all clear till here, which means we can move ahead. Now, the next thing we're going to start to learn is some constructs like if, else, for loop, because these are something that we need to know in order to perform further operations on top of strings and various other um, data structures as well. And there are some other operations such as and, not, or which we're going to use. Just so you know, we haven't worked on some very basic operations on arithmetic operations as well. That's something we need to start ahead. And we're going to do some basic programs on these before we get to the core concept of Python, which is data structures.